Hello everyone. This video on algebraic identities is in continuation to the previous video. In this we would be discussing expansion for cube of binomials. First one, which we have already seen in the previous video, x plus y whole cube is equal to x cube plus y cube plus 3 times xy into x plus y. This we have already seen and application also has been checked in the previous one. Next was x minus y whole cube, which is x cube minus y cube minus 3 times xy into x minus y. Two more we would be learning, which are x cube plus y cube. This would be equal to product of x plus y and x square minus xy plus y square. In fact, this identity is obtained from the topmost identity only. After simplification, we would get this result. Another we have x cube minus y cube, which can be written as product of a binomial, which is x minus y, and a trinomial x square plus xy plus y square. Now let us check the application of these two new identities.
Let's check the application of these identities. Question says factorize 27y cube plus 125z cube. Now this cube, these two cubes indicate that the numbers over here, the numerical figures which are written here, must be written in perfect cube formation. 27 is 3 cube, so 3y whole cube added to 125 can be written as 5 into 5 into 5, which makes it 5z whole cube. Now this is nothing but identity which we have just now seen, that x cube plus y cube would be expressed as product of binomial x plus y and a trinomial x square minus xy plus y square. Let's expand, let us put this in factor form. So that formation would be, our first factor will be 3y plus 5z. Second factor would be 3y whole square minus xy means product of 3y and 5z, and then comes square of second term. So first factor 3y plus 5z remain as such. This would be 9y square minus, what's the product of these two? 15yz plus 25z square. So these are two factors obtained after factorization of 27y cube and 125z cube. I'm sure this must be clear.
Now the most important identity with us, which is the last one from this chapter, last but not the least. It is x cube plus y cube plus z cube minus 3 times xyz. It is actually equal to product of a trinomial x plus y plus z with x square plus y square plus z square minus xy minus yz minus zx.
Now we are going to discuss another most important identity, which is actually obtained by product of this trinomial with this polynomial, and this would land up and become x cube plus y cube plus z cube minus 3 times xyz. In most of the times you would be in fact given this expansion and the question would be factorize this. So factorization would be product of trinomial and this multinomial. Alright, so let's begin. The proof for this, although would not be asked, but still I would share with you. We need to multiply this x with all 6 terms, then y with all, and then finally z with all. And on simplification you would see most of the terms would cancel and finally it would be x cube plus y cube plus z cube minus 3 times xyz. Let's do it.
So we are picking up RHS and we are multiplying them. X multiplied by x square plus y square plus z square minus xy minus yz minus zx. Then y would be multiplied by x square plus y square plus z square minus xy minus yz minus zx. And finally comes this z. This would also be multiplied by all those 6 terms which are listed here. Now next step is, let's do the multiplication. X into x square would be x cube xy square. This is simple multiplication. X z square. X into xy, x square y. X into minus yz minus xyz. X into zx with negative minus zx square. First is over. Move on to the next. Added to y, x square plus y cube plus yz square. Okay, 3 are done. Minus y into xy would be xy square. Y into yz with negative would be y square z, and y into zx would be xyz. Now the last one, zx square zy square and z cube minus xyz minus yz square and minus z square x. Okay, all the terms are listed. So 6 plus 6 plus 6 makes it 18 terms. Now most of the terms you would see would cancel. Now let's check which terms can be cancelled. X cube cannot be cancelled with any term. Xy square, this is positive. You would definitely find one xy square with negative. So here we go, these two are cancelled. Xz square positive, xz square negative, this finishes off. X square y negative, then x square y positive, this also finishes. Xyz with negative. Do we have any xyz positive? No, there are two more but both with negative. Zx square negative, zx square positive, this finishes off. Y cube cannot be cancelled. Yz square positive and yz square, look for yz square. We have yz square negative, so this also finishes off. Y square z negative, y square z positive finishes off. Let's see what are we left with. So finally we are left with the terms x cube minus xyz from here, then it's y cube, then one more xyz plus z cube and xyz. When you write it in arranged or rearrange them, you would see it actually becomes x cube plus y cube plus z cube minus xyz, xyz, xyz is 3 times. If minus 1, minus 1, minus 1, we take minus common, all 3 are added, so it's minus 3. Right over here also it's minus 3 times, list all the variables x, y, z. So we took RHS. On simplification of RHS, this is equal to LHS. So hence this is how this identity, most important identity, has been verified. Let's check the application of the identity we have just now discussed. This is something of the same form. This is
a cube plus b cube plus c cube minus 3 times abc, if it can be written in that form. We know 27 is a perfect cube for 3, so it's 3x whole cube. This is y whole cube. This would be z whole cube minus 3 times x, or you can say 3 times a, then b and c. So this formation would be for 27x cube plus y cube plus z cube minus 9 times x, y, z. In the next step, we know that this is going to be the factors. We need to simply write the factors now using identity. Let me write the identity using some other variables. A cube plus b cube plus c cubes minus 3 times abc is always equal to product of a trinomial, which is a plus b plus c, and a multinomial or a polynomial, which is a square plus b square plus c square minus ab minus bc minus ca. So let's put this in factor form. So this becomes 3x plus y plus z. Okay, over here it's a cube plus b cube plus c cube, so a plus b plus c, or 3x plus y plus z is done. Second one, a square, 3x whole square, b square, y straight away you square it, z square, then minus ab means multiply these two, minus 3 times xy, minus bc, it's minus y into z, minus ca, this into this, 3zx. And finally, the factors are 3x plus y plus z, 9x square plus y square plus z square minus 3xy minus yz minus 3zx. That's all. This is how this has been factorized. It means it has been put in factor form. Now we are discussing question number 12 from exercise 2.5, one of the most important questions. Identity is same, but now it is given as product of x plus y plus z, and inside you see expansion. There is a possibility for expansion of these terms. So we would be picking up that end which can be further simplified. So I would be taking right hand side, and RHS over here is half of x plus y plus z, that remains as such. Let's now open the bracket. We know x minus y whole square would be nothing but x square plus y square minus 2xy. Y minus z whole square is nothing but expansion for y square plus z square minus twice of yz. And then comes expansion for the last one, which would be z square plus x square minus 2zx. Let us see what's the next step. Let's put the like terms together. Half comes common, half remains as such. X plus y plus z. X square is once, x square is one more x square. So it's twice of x square. Y square is also twice. Once it's over here, once over here. So twice of y square. Z square is also occurring twice, twice of z square. Then minus 2xy minus 2yz minus 2zx. And in the next step you would see this becomes, can we take 2 common from all these terms? All 6 terms have got 2, so bring it out, and 1, 2 is already in the denominator. What are we left with? This is x square plus y square plus z square minus xy minus yz minus zx. This is simplified, and we already know this expansion we have just now discussed. X when multiplied by all 6, then y and then z would actually give you x cube plus y cube plus z cube minus 3 times xyz. Kids, let me tell you one thing more. You don't have to to simplify it by actually multiplying, you would straight away say applying identity. Applying which identity? Number 8. Or applying the identity as such you can mention, and this formation would be equal to x cube plus y cube plus z cube minus 3 times xyz. I am sure this must be clear.